Hello judges, we are from Team TechFair and we are working on the problem statement 1463. The problem statement states that we need to build a server log system for e-governance for the AICTE, and the server log system has to make a content-based classification system and also needs to provide notifications in appropriate times. So we have divided our project roughly into three parts. The first part is centralized log management and analysis. What this is essentially going to do is it's going to collect all the logs and going to analyze them and classify them based on whether they are error logs, whether they are system logs, whether they are notification logs, what type of logs they are. Based on that, we're going to classify them. We're going to use WebSockets for log collections. When a log hits the AICT server, it's going to directly be sent to the log server for storage. And after that, we are going to use recurrent neural networks for log segregation and pattern detection. Using this, we'll be able to classify which log belongs to which category. And we are also going to have data visualization, and we're going to have some types of insights based on the logs that are going to be classified here. And we're also going to have time-based log retention. That is, like if the user wants the logs deleted after 1 hour or maybe 2 hours, we can have that using time-based log retention. We're also going to have a robust automation and integration. This involves that our log analysis system will be heavily automated. Very less amount of manual work will be required to add a new server, to update the server configurations, to install new files inside the server. We will not require any kind of manual work for that. All of it will be automated. Uh, we will have seamless integration of these central log APIs globally accessible so that we can integrate this application with any other application that is available on the internet. We'll create a module bundle, especially a module bundle which will be installed into the server system using command line, which helps us in server provisioning. This module bundle will contain every kind of files and folders and types of softwares or versions of softwares that we need to install for the server code to run effectively. This helps us in automating the entire process, and no kind of manual labor will be required to get the server up and running. We'll also have continuous monitoring of the server resources, as in the traffic, the CPU, memory occupied, disk space, and the time that the CPU uses. All of these factors will be continuously monitored using an automated tool in the central log management server. So anyone who has access to the server will be able to view all of these files, view all of these monitoring data. We'll also have automated patch management, as in if we want to control the version of a particular server, if you want to control the version of the operating system or the version of the files that are running or the version of the modules that we are using, we will be using an automated system for that using SSH. We'll be using shell scripting for that to install new versions and keep all the servers up to date. We'll also have data backups in a separate database in case we have any kind of data loss. This will prevent us from permanently losing all the logs that we have in our log storage server, and essentially we are not losing any kind of data. We're also using log analysis to visualize all the log data that is coming in. We're also having a load balancing algorithm where we'll be using least connection load balancing and round robin load balancing to optimize the server loads. So this is what our structure would roughly look like. Let's say this is the internet and the requests are coming in from here, and we have a load balancer right here which is evenly distributing the load to all the AICTE servers that are existing, and the server log data is going into our log server using a socket connection. So the data, once any kind of log is created in these servers, is directly going into the log server via a socket connection, and it's being stored over here inside a time series database for compliance. For like 2 hours, the logs can be stored for 1 hour, 2 hour, 3 hours, as much time the user sets, and this can be updated every now and then. And we'll have APIs for this log server which can be globally accessible. Thus, this log server can now be integrated with any other application, and we'll also be having a socket connection to visualize and continuously monitor every kind of data that is going into the log server, such as the time, that is time that is being occupied by all of these servers and all the other data that we are getting. We're also going to classify every log that is coming into this server using machine learning algorithm, which we'll explain in the next slide. Also, what we're also gonna do is we are gonna use another kind of connection to install new servers. Suppose we have the hardware configuration with a preloaded operating system inside the server machine. We are going to use shell scripting using SSH, which is secure shell, and we're gonna run some Unix commands to install the module bundle that we're going to be using, which is gonna help us in running the server side code for AICTE in these servers, and thus no kind of manual labor will be required to set up these servers and configure them such that these can be connected into the entire server environment. Moving on, to classify every log using machine learning, what we're going to do is we're going to calculate some metrics. We're going to see the performance metrics, we're going to see the security metrics, we're going to see error and exception metrics, we're going to see infrastructure metrics, and we're also going to see the application specific metrics. These metrics helps us classify in what type of log we are creating. For example, if we want to see whether the log that is coming in is an error and exception log or not, we need to see whether these types of metrics or these types of messages are existing inside the logs or not. So it's, if it has an error code, it's probably an error metric. So we will be using these types of metrics to classify what log is what. So we are also going to do server provisioning and maintenance. We're, as we said, we are going to have a load balancing tool. We're going to have a socket connection to get the real-time logs. We're also going to use SSL secure shell to interact with the servers remotely and install all the modules. And this is going to be all in real time. And it also helps us get the server up and running remotely. And the entire system, the entire application helps in roughly three things: the real-time monitoring of the servers, it also helps us in updating the server versions, and also helps us in provisioning all the servers. It also helps us in real-time monitoring of all the server data such as time taken, CPU exhaustion, and also helps us in storing all of the data in a database and also in a backup database. So that's all for our project from Team TechFer. Thank you so much.